In 2015, TC39, the committee that defines the JavaScript language standard, published ECMAScript 2015, which included something the language had needed for 20 years, an official module system. Every major programming language had modules. Python had them. Java had them. Ruby had them. JavaScript had spent decades without a formal module system, relying on community conventions like CommonJS and AMD. That changed with ES 2015. ECMAScript modules, or ESM, use two keywords, export and import. You mark what you want to expose with export, and you declare what you need with import. Unlike CommonJS's runtime require, ESM imports are static, they appear at the top of the file, and the module system knows exactly what every module needs before any code runs. To use ESM in Node.js, you have two options. You can use the .mjs file extension m for module. Node.js treats any .mjs file as an ESM module automatically. Alternatively, you can add type module to your package.json, which tells Node.js to treat all .js files in that package as ESM. Without one of these signals, .js files are treated as CommonJS. ESM supports named exports exporting multiple things by name and default exports exporting one primary thing that importers can give any name. You can mix both in the same module. Named exports use export const name equals value or export name. Default exports use export default value. The import syntax mirrors this: import name from /module for named, import anything from /module for default, and import default thing, name thing, from /module to import both simultaneously. Here's where ESM reveals its most significant design difference from CommonJS, and why that difference matters for large applications. CommonJS loading is simple. Require runs the file synchronously. When you call require ./module, Node.js runs module's code right now, on the current call stack. The result is whatever module.exports contains when the code finishes. ESM loading is fundamentally different. It happens in three distinct phases, and no user code runs until all three phases complete for the entire dependency graph. Phase 1 is construction. Node.js reads every ESM file in the dependency graph, your entry point, everything it imports, everything those files import, recursively, and parses them to find all import statements. This is purely about discovering what files exist and what they need, not about running any code. Because import statements must be at the top level and cannot be inside conditionals or functions, the entire dependency graph is known statically before execution begins. Phase 2 is instantiation. Node.js creates memory slots, called bindings, for every exported value from every module. The modules are linked together, each import points to the memory slot of the corresponding export. But the slots are empty at this point. No values yet, just the connections. Phase 3 is evaluation. Now the code runs. Each module's code executes in order, filling in those memory slots with actual values. The connections established in Phase 2 mean that as soon as a value is written, every importer that references it sees the new value immediately. This three-phase process is what makes ESM's live bindings possible, and it's the fundamental architectural difference from CommonJS. This is the single most important behavioral difference between CommonJS and ESM exports, and it's the source of genuine confusion when developers migrate between them. In CommonJS, when you require a module, you receive a copy of that module's exports object at the moment of requiring. If the exporting module later changes a value on its exports, you don't see the change. You have a snapshot in time. In ESM, exports are live bindings. When you import a value from an ESM module, you're not getting a copy of the value, you're getting a reference to the memory slot where the value lives. If the exporting module updates that binding, every importer sees the updated value. This is a live connection, not a snapshot. The book demonstrates this with a counterexample. An ESM module exports a count variable and an increment function. When external code imports count and calls increment, the count they see goes up, because their import is a live binding to the same memory slot that increment writes to. In CommonJS, the same pattern would show the initial value forever. You'd have to re-require the module or export a getter function to observe changes. Live bindings also solve the circular dependency problem more cleanly than CommonJS. Remember the CommonJS circular dependency issue: A requires B requires A, B gets an empty object because A hasn't finished executing yet. With ESM's three-phase loading, the instantiation phase creates all the bindings before any code runs. So when evaluation starts, B's import of A already points to the right memory slots, they're just not filled yet. As it evaluates and fills its bindings, B's reference to those bindings automatically sees the values, whenever B's code actually accesses them. Static imports, the import statement at the top of a file, are the foundation of ESM. But they have a real limitation: they must be at the top level, outside any function or conditional block. You cannot conditionally import something based on runtime data. You cannot import a module whose name you don't know until the program runs. You cannot lazily load a module only when it's actually needed. For all of these cases, ESM provides dynamic import. The syntax is import, a function-like expression that takes a module specifier and returns a promise that resolves to the module's namespace object. Because it returns a promise, you can use it anywhere promises are valid inside async functions, and then, chains, anywhere at runtime. You can compute the module path dynamically. You can conditionally import based on environment variables or configuration. You can defer loading an expensive module until the moment it's actually needed. Dynamic import is how modern front-end bundlers implement code splitting. Instead of bundling everything into one file, they load chunks on demand when the user navigates to a part of the application that needs them. In Node.js, dynamic import is also the mechanism for importing ESM modules from common JS code. This is a critical interoperability point. You cannot use require to load an ESM module because require is synchronous and ESM loading is asynchronous. But you can use dynamic import from common JS code to load ESM modules because import returns a promise and handles the async loading. This one-way door ESM can statically import CJS, but CJS must use dynamic import to load ESM, shapes how you structure mixed codebases.